Hey, hi friends, very good morning to everyone. So, sorry, I was a bit late to join the session. Okay, so last class we were discussing about various components of Oracle architecture, and we stopped at the point of starting with the background process, that is SMON. So, before we understand the responsibilities of SMON, we need to know a little bit more about the redo log files. And well, before going into that as well, I would like to now tell you about something called SCN number. So, if you just recollect one of the sessions of DML processing, so I told you that for every change, whatever happens in the database, Oracle is going to generate a redo entry. And I told you that redo entry is nothing but a log kind of information that Oracle is going to maintain, in which it is going to record what is the date and the time at which the change has happened, and in which table this change has been taken place, and in which table space the change has taken place. Then what is the new value that was inserted into the block, and whether the change was committed or not committed, maybe at that particular moment of time. And I also told you that it is going to record a SCN number, so which stands for system change number. So now what is this system change number? So many DML statements or DDL statements might be getting executed in the database at a particular given point of time. So for example, assuming that some hundreds of transactions are happening in the database, so obviously each and every transaction, let's say they all hitted the database almost at the same time. So what happens internally is, uh, in between nanoseconds of time, these transactions will get executed. So let's assume a situation. So 11 o'clock, 20 minutes, 30 seconds, some 100 transactions hit the database at the same time. So even if you take a look at the transaction execution time, so let's assume even not even seconds, it will take or in microseconds of time, the changes are getting executed at database level. So let's say 0.3 microseconds, the first statement get executed. Then 0.5 microseconds, second statement got executed, and 0.8 microseconds, third statement got executed, like that. So if Oracle wants to really capture the date and time at which this execution takes place, it may go to it need to go to till micro level, microseconds recording. So that will be usually very tough for a computer system to record even at that particular level. So what Oracle will do, it will not record this micro information. Rather, in this particular date and time where I talked about, it will record only hours, then minutes, and then seconds. It will not record for the microseconds and nanoseconds kind of information. So to maintain this microseconds and nanoseconds information or the difference, Oracle is going to maintain this system change number. So what it will do is, when you create a database, it will start newly with the SCN number of 1. And whenever the changes are keep on happening in the database, this number will keep on getting incremented by +1. So 1 will become 2, 2 will become 3, then one more change happened, it will become 4. So like this, the number will continue. So when at this 03 microseconds, the first change happened. So instead of storing this information, as I said, it will store only hours, minutes and seconds. And then to represent this 03 seconds, at that particular moment, what is the SCN number, it will record that. For example, 2145 is the SCN. So that information will be recorded in this redo entry. Now taking the second redo entry, so the time is same, 11 hours, 20 minutes and 30 seconds. But because this is another change happened to the database, this number will be incremented by +1. So similarly, if you take the third one, again it is same. The time will be same, but the number will be different because this is another change happened. So like this, the number will keep on getting incremented, depends on how many changes are happening in the database. And this we call it as system change number, or shortly SCN. So we can say SCN number is like a clock to the database. So instead of storing the actual date and time, I mean it will store the date and time but only till seconds. But if you want to go deeper till microseconds or nanoseconds, for a computer system it is very much because depends on the other processes and all, it is very much not possible. So Oracle is going to depend that with the help of this system change number. So that is about SAN and what is its use. So here tomorrow, like let's say you lost some data and you want the database to be recovered. In that case, we can specify to which SAN number we can be able to recover. Let's say I want to recover to a particular SAN, something like 1974. So like from 2147, that is the latest SAN, and if I make my database to be recovered to 1974, it means that I am going to recover to the past SCN. So maybe this 1974 is going to be represented with some date and time. So to that date and time, your database will be recovered. So like that, we have different options for recovery, but we have that advantage. Instead of mentioning the date and time during the database recovery, we can even mention the SCN number as well. So, and we have different types of SCNs as well. So we will be seeing those information at later point of time.
So is there a table that stores SCN number?
Sorry, can you come again?
Is there a table where SCN numbers are stored?
Not exactly the past SCN, but it is going to record the current SCN information always.
Okay.
So the past SCN will anyway be there in the redo entry. Got the point? So
And one more question is when you said 2145, right? And 2146, 2147. So those are transactions, right? When you say 2145, it's a committed transaction? Or you just say like one DML update, like it's an update statement, and then 2146 is another update statement, 2147 maybe delete operation.
yes,
Or is it
exactly.
a transaction like committed or?
Or it can be also like this: one statement which is which is changing multiple values. It is
Okay.
not necessary that these three should be different statements. It can be also like one statement, let's say one update statement, which is modifying some 100 rows one by one. So in that case also, like because 100 changes are happening, for each and every change, this number will be different. So that can be also the possible situation.
Okay.
Okay, so the old SCN information will always be there in the redo entries, and database only will maintain the current SCN number. So, anyone having any more questions?
Yeah, one doubt. The redo log entry will, I mean, say, when it is committed or not committed, one SCN change will happen, right? So after committed, again, the SCN change, there will be change in SCN, or it will remain the same thing.
The SCN will remain same, only that commit flag will get updated. So
Okay, thank you, Pawan.
yeah, no problem. So there is much more, in deeper details, but which may not be required, and it will be much more confusing. So that's the reason I'm not going to that level. But as you know, you can remember that that commit flag, whatever is there, so it will be like yes or no, the Boolean value. So it will get updated.
Okay, Pawan. Thank you.
No problem. So any more questions from anyone? Okay, so let's move on to the things for today. So prerequisites for SMON. So before we jump on to understand the responsibilities of SMON, we need to know a little bit about how the redo log file management will be happening in the database, and also we need to understand something about that. So having said that, for each and every change there will be redo entries generated. You can understand, like for 100 rows, let's say, or 100 values you want to do some change. You can understand 100 data blocks need to be modified, and also undo blocks need to be modified. So much of redo entries will be generated in the database. So let's assume initially I have allocated some 20 GB to, I have one redo log file, assuming that. So I have allocated some 20 GB to that redo log file. Now when more and more changes are happening in the database, definitely at one moment of time, this 20 GB will be filled up, and of course we need to add some more space. So let's say I added another 20 GB. So that will also be filled up by some other time, like say after 3 days or after 1 week, something like that. So going forward, you keep on adding the space, and your redo log file will keep on occupying the space. So at one moment, it might go into a terabyte size as well. Now, definitely all the clients cannot, go with the space purchase. Like there might be some restrictions. So if the actual data, and moreover the thing is, if the actual data itself is very small, and only these changes are taking huge size, then nobody will be interested in purchasing the data, I mean, Oracle RDBMS. So something like, for example, let's say you purchased an antivirus software, and that antivirus software is generating some report daily, and it is giving you some scan report or something like that, and that scan report is keep on taking more space in your computer. So definitely you will not use that software. Instead of that, you will purchase some other software. So similar will happen even for the Oracle RDBMS as well. So Oracle need to have this it need to implement some management, especially for the redo log files. So what Oracle has done for that is, instead of maintaining one redo log file, as you can see in the picture, it is going to maintain two redo log files. And what it will do, it will make logwriter to write into both the redo log files in a cyclic order. And that is where the arrow marks given there are going to show you that one file is full, then logwriter is going to move to second file, and it is going to start writing into the second file. Now, uh, obviously, when you have completed writing into one file, let's say this is first redo log file, and this is the second redo log file. So logwriter started writing into this. So once it is full, it will move to second file and it will start writing here. Again, it will come here and it will start overriding here. So now when you override it, obviously the previous information is gone. Then Oracle has given you two options. One is, if you don't want to have the previous information, simply logwriter will keep on overriding the existing information. No, if you feel that no, I don't want this to get overridden, or before getting overridden, I want to have a backup of this, then yes, Oracle gives you an option called archive log mode. So if you enable this in the database, then before overriding, before logwriter overriding, there is a background process called archiver. So this background process is going to take the backup of this information in some other location. Of course, for that also we need space as well. But instead of immediately doing that, Archiver will do the job slowly. So that option is there. So by default, this mode will not be enabled even in 12c database. So we need to manually enable it. Depends on the requirement. So for example, we have different types of environments. We'll be discussing about it. Like we will be having development database, testing database and all. So depends on the criticality of the environment. Either we enable this or we disable this. But when we enable this, this archiver background process is going to take the backup of these files into the location where we specify. So once archiver completes taking the backup, then only logwriter will be able to write into that particular file. And logwriter moving from one redo log file to another redo log file, Oracle has given a name to that jump, which it is called as log switch. So switching from one redo log file to another redo log file, we call that as log switch. Now when log switch happens, there are certain events that will take place in the database, and we need to understand what are all those events. So basically there will be 3 or 4 events takes place in the database. So the first is checkpoint event will occur. Now what is this checkpoint means? So checkpoint is the name of the event, so that will take place in the database. Now what exactly is this checkpoint? You can read there. It is to make sure that the DB writer should write the dirty blocks to the data files. So which means, so let's say checkpoint event happened at this particular moment. So let's say the time is 6:36 40 seconds. So then till this moment of time, whatever the dirty blocks are generated, so dirty blocks, once they are generated, they will be copied onto write list. So whatever the dirty blocks that are there in the write list, so DB writer need to write them into the data files. So that is the event purpose. The purpose of having the checkpoint is like that. Now let's say again next checkpoint occurred at 6 hours 37 minutes 0 seconds. Then in this 20 seconds, means earlier the previous checkpoint occurred at 6:36 40 seconds. The latest checkpoint occurred at 6:37. So in this 20 seconds, whatever the dirty blocks generated, again DB writer should write them to the data files. So this is what it means by checkpoint. So you can assume or you can just correlate this with the same thing like automatic email saving in Gmail or something. So let's say you people know that when you open Gmail and when you try to compose a new email, and let's say you are taking some time to write down an email. So what happens, it's like every 1 minute or so, automatically whatever the information that you have written, your Gmail application is going to save that as a draft. So finally, whether you will be sending that email or whether you will be discarding that email, it is up to you. But at that particular moment of time, it is going to automatically save that things. So similarly, here also, whether the data is committed or not, the only responsibility of this checkpoint event is to make DB writer to write the dirty blocks to the data files. Whether the data of the dirty blocks is committed or not, it is irrespective. So as the same point also I discussed in the last class, that it is not necessary that only committed data will be there in the data files. I told you that uncommitted data also can go to data files because the Oracle's functionality is designed in such a way. So that is about the checkpoint event. Then we have a background process called CKPT. The name is also called checkpoint process. So don't get confused between the checkpoint event and checkpoint process. So that's why it is better to call it as CKPT process. So what this background process will do is, as you can read here, it will update the latest SCN to the data file header and control file by taking the information from the redo log files. So let's say, so this is my first redo log file and this is my second redo log file. So assume log writer started writing into this. And it has performed a log switch. So as per the point, what it is saying, there is a background process called CKPT and it is going to update the latest SCN number to the data file header. So every data file will have a header portion. So just like how a human body will be having a head portion, so data file also will have head portion where it is going to store some information. So we call that as data file header. So CKPT will update the latest SCN number to this data file header as well as to the control file. So the question here is from where it is going to take the latest SCN. So the latest SCN is nothing but the last redo entry in the redo log file. Suppose this is the last redo entry in the redo log file. So automatically this will be having the SCN number. So let's say 2842 is the SCN number. So this is the latest SCN number. So then CKPT will write that latest SCN number 28422 to data file header and control file. Then let's say log switch happened and the log writer started writing here, and again a log switch happened from second file to first file. In that case, so whatever the last redo entry again that was written, for example here this one, so assume the number is 3184, then CKPT will replace or it will erase the old SCN number, and it will write this the latest SCN number to both data file header and the control file. So every time this happens, like this will be a forever activity. So whenever the information or whenever the checkpoint event occurred, this CKPT is going to record that latest SCN information to this data file header and control file. Why it will do that and all, you will understand once we saw an example for SMON's responsibility. But as of now, you can remember this is what CKPT process will do. And of course, because in the first point we said that checkpoint event occurs, so DB writer will write the corresponding dirty blocks to the data files. That is the third action that will take place in the database. And if the database is enabled with archive log mode, as a fourth action, archiver process will take the backup of the redo log file, as I said, into some specific location. But if you don't have archive log mode enabled, then this fourth step will not be performed during log switch. So all these four steps will be performed at the time of log switch, that is log writer moving from one redo log file to the another redo log file. Now here the question is when the checkpoint event will occur. So checkpoint event will occur at the time of log switch, that is for sure. But along with that, checkpoint event can also occur at specific intervals. So let's say I want checkpoint event to occur every 30 seconds or every 60 seconds. So I can decide the time factor as well with the help of a parameter called fast start mttr target. So this we need to specify in our parameter file. So for example, if I say this as 30, which means seconds, so the unit here is seconds. So if I say fast start mttr target as 30, it means that every 30 seconds I want checkpoint event to occur. So when checkpoint event occurs, automatically the further actions will take place, like checkpoint process will update the latest SCN to data file header and control file, and also DB writer will write. So archiver process will not be writing here. Archiver will work only if the redo log file is full. So if the redo log file is not full, then archiver will wait till the redo log file will be full. So only thing is when checkpoint event occurs, these two actions will take place always. CKPT process will update the latest SCN, and DB writer will write the dirty blocks into data files. Now every 30 seconds will be a too much less value, because you are giving sometimes you may put an extra load on the CKPT process and DB writer process. So let's say I just mention this value as 120 seconds. like every 2 minutes. That might be a very high value, and in case of any crash or something happens, the recovery time will be more. So that is the reason the advantage what Oracle has provided is simply we mention the value as 0, which means Oracle is going to automate this checkpoint event process. So 0 equals to auto mode. Oracle by itself will decide when to initiate the checkpoint event. Sometimes it may initiate the checkpoint event within 15 seconds itself, or sometimes it can initiate the checkpoint event after 2 minutes also. Like that, it is going to decide on its own, and that is where we are going to declare this parameter fast start MTTR target is equals to 0. So that is about when can a checkpoint event will occur. So now let's understand the responsibilities of SMON. So SMON is one of the critical background process of the database, and it can be as a part of the mandatory background process as well. So it means that if SMON background process is not up and running, it means that your database is down. Or if you kill a small process by mistake or something, then automatically the database will go for crash shutdown. So it is mandatory background process to be keep on up and running. So it is having different responsibilities. The first responsibility is instance recovery. So what is means by instance recovery? So as we know, instance is comprised of the background process as well as the memory structures, SGA. So either if any of these memory components fail to work, or if any of these background process fail to work, then automatically instance crash will happen. Like you can see, there are different reasons like power failure, all of a sudden power failure, or RAM failure, or any memory related issues. So all this will fall under the instance crash situation. So when instance crash happens, and when you again try to fix that, and you restarted your database, then instance recovery will take place, and that will be handled by SMON itself. So it will handle this instance recovery in two phases. One is called as roll forward, and the second one is called roll back. So we will try to understand with an example what is mean by roll forward and what is mean by roll back. So roll forward means if if there is any data which is marked as committed, so that data should be there in the database, obviously. So if some transaction is committed, obviously we need to have that information in the database. So we cannot say to the customer that your data is lost. So for that, to understand this roll forward, we have taken an example here. So let me put that over here as well. So I am taking a situation where I have one redo log file. So log writer started writing into first file, and it has written some redo entries with respect to SCN number 1, and it has written some redo entries with respect to SCN number 2, and this underline whatever I am drawing, just assume that that is a commit point, means 1 is committed at this particular line, or 2 is committed at this particular line. Then log writer started writing 3, so it has not yet committed, assuming that 3 is a bigger transaction. So the first redo log file is full, Then log writer started writing into second redo log file. Because log writer moved from one redo log file to another redo log file, obviously log switch will happen. And we know already when log switch happens, multiple actions will take place. Like checkpoint event will take place first. Then checkpoint process will update the latest SCN to data file header and control file. So data file header in the sense all the data file headers. So let's say if I have 30 data files, to all the 30 data files, the same number will be updated. So here if you take a look, the latest SCN is number 3. So CKBT process will write that number 3 into data file header and control file. And also we know that DB process will write the dirty blocks. So DB assuming that it has completely written data with respect to 1, and it has written complete data with respect to 3, and it has written only half of the data with respect to 3 because 3 is still going on. It has not yet committed or it is rolled back. The transaction is still going on. So assume only half of data of the 3 has been written to the data files. So here if you take a look, 3 is not committed, but still its data is there in the data files. Now take a situation, 3 is committed, but its data is not there completely in the data files. So right now log writer is writing redo entries with respect to SCN number 4. At this moment of time, assume instance crash happened. So as I said, instance crash means all of a sudden it could be a power failure or RAM failure, or it could be any other memory related issue, or somebody by mistakenly killed one of the mandatory background process. So it could be anything like that. So assume instance crash happened. So you fix it that problem. Let's say RAM failed because of hardware failure. So you replace it with a new RAM and you started your database. So when you start your database, SMON will come into picture because system or database went for the crash recovery. So SMON will come into picture and it will do the roll forwarding. Now what is mean by this roll forwarding? We need to make sure committed data is there in the data files. So for that it is going to do the activity like this. So first it will start scanning the redo log file, the first redo log file. So first it will check or it will compare the SCN number between the redo log file as well as the data file header and control file. For example, in the redo log file, the first, this is data file header and this is control file. So in the redo log file, the first SCN I got is number 1, and in the data file the latest SCN I have is 3, and here the in control file as well I have the number as 3. So always it need to be sure that the number in the redo log file should be either same or greater than the number what is there in the data file header. So 1 is less than 3. So it will check whether one data is committed or not. As I said, yes, here this underline represents it is committed. Now it will verify whether data of 1 is completely there in the database or not. Yes, the data of 1 is completely written already before the crash itself. So do I need to recover anything for transaction 1? Not really. So it will just skip that. Then it will come to the second redo entry. So the second redo entry SCN number is 2, then data file header is 3, control file header is 3, and it is committed, and 2 data is completely there in the data files. Yes, it is there. so nothing to recover for 2 as well. So when comes to the next one, that is 3, and in data file header and control file also the number is same. Now whether this transaction is committed, that by scanning the first redo log file, SMOD will not be able to understand whether this transaction 3 is committed or not. So what it will do, it will start scanning the second file. So when it starts scanning the second file, at this particular moment, it will understand that yes, the second file is also, the transaction 3 is also committed. But do I have complete information about 3? No. In the data files, complete information of 3 is not there. Only half of the data is written. So then SMON will need to recover this or not? Yes. SMON need to recover transaction number 3. So what SMON will do? SMON is going to ask DB writer to finish writing the remaining half of the data. So half of the data is already written to the data files. So the rest of the half need to be written by DB writer. So SMON will initiate DB writer. So DB writer will go to your write list, which is there in the database buffer cache. But just now you restarted the database, and when you restart the database, nothing will be there in the memory structures. Like your shared pool will be empty, your database buffer cache will be empty, and all other memory components also will be empty. Why? Because all these components are part of RAM, and we know that RAM is volatile. Whenever you restart, all the information in the RAM will be cleared. So DB writer, even though it comes down to write list, it will not be able to identify the dirty blocks. So to generate the dirty blocks at that particular moment of time, DB writer will take the help of server process. So what server process will do, just like how we discussed in DML processing, server process is going to do that a dirty block generation. Like it will copy the data block, undo block. In PGA, modifications will happen. So we already understood that. So same things will take place here. But the question here is how I would be knowing what is the value that I need to insert. Because if I need to generate dirty block, means I have one block here. Already it is having value of 100. How I will be knowing that I need to update this value from 100 to something else? How I will be knowing that new value? So if you remember, redo entries will be having this new value. So when we discussed, I told you it will store date and time, table name, table space name, etc., etc., and it will also store the new value. So server process will take the help of this redo entry, which is having the new value, and it will generate the dirty blocks. And then once we have those dirty blocks in the write list, DB writer will complete writing in the remaining blocks for the transaction number 3, making or recovering it to the up to the time. So which means that transaction 3 is committed, but complete data of 3 is not available in the database. So SMON took the responsibility of recovering or completely writing the information with respect to transaction 3 in the database. So for that it will make use of this redo entries or the new value, but what is there in the redo entries. So this is the one of the steps that it will do during instance recovery. So what basically SMON here is doing, it is comparing the SCN number first, then it is verifying whether the data is committed or not, and it is making sure the data is there in the data files. If not, it is initiating the DB and of course DB in turn will take the help of server process to generate those dirty blocks and write them to the database. So is that clear or anyone having questions?
So Pawan, are you going to take that example when the checkpoint number is 4 in the redo log file?
Yeah. So now coming back to here in this example, if we take a look at 4, now Smon will scan that one as well. Smon will not stop there. So then in redo log file, the number is 4, but in data file header, still the number is 3 and control file also number is 3. Then Smon will verify whether transaction number 4 is committed or not. It is not committed. So SMON doesn't bother about not committed or uncommitted data. So nothing to recover for transaction number 4 in
So,
this
so,
particular example.
so is it safe to assume whenever the number is greater in the redo log file, that means it will have uncommitted transactions?
Only in case of instance crash.
Okay.
So taking for example, let's say 4 is also committed. Then in that case, yes, SMON is having the responsibility that it need to even recover transaction number 4 because it is committed. So in that case again it will do the same thing. It will ask DB data and DB data will take help of server process to generate the dirty blocks with respect to 4, and finally those blocks will be returned to the data files. And the moment 4 was written, because 4 is the latest SCN, your data file header and control file numbers will get updated to that 4 automatically. So till now it is 3, but now because we have 4, so that is the latest SCN, so that will be updated to your data file header and control file. So that is about the roll forward example. So the same thing whatever we have discussed, I have represented it here. So once it has done the recovery for the committed transactions, then it will open the database for the user access. And if there are any uncommitted transactions are there, then SMON will perform a rollback on those uncommitted transactions. Now, how it is going to do that? So even we have one more example for that. So I'm taking the similar example, but with a small difference. So assuming that logwriter has taken, completed writing into that, and we have the logs which occurred. So here the latest SN is 3, so it will be written to data file and control file things, and we have the transaction details like this. Half of the 3 was written. So in this example, I am taking 3 is not committed. Still the details, I mean the redo entries of 3 are being written in the second redo log file by logwriter. So at this moment of time, instance crash happened. So we know that when you restart the database, so SMON will start doing the recovery. So the same things will happen. It will try to compare the number between redo log file and data file header and the control file, and also it will look at commit and not commit point. So for one, everything is there, so no need to recover. And for 2 also, everything is there, no need to recover. So when comes to 3, so again, as I said, from the first file, it will not understand the information. So SMON will start scanning the second file. Then it will understand that the transaction is not committed. So also SMON will realize that even though transaction 3 is not committed, already the data was written to the data files. So now what I need to do, whatever the data that was already there, I need to just erase that data. So I erase in the sense I just need to remove that data because the transaction is not committed. So how it is going to remove that or erase that? So erasing in the sense it is going to do a rollback. And you already know that if at all we need to do rollback of a transaction, we need to make use of undo values. We have an undo table space where we will be having the old values. So what SMON will do, SMON will take the help of server process, and it will, server process in turn will take the help of the undo values, and it is going to roll back transaction number 3. So rollback is nothing but whatever the data that was written already for transaction number 3. So now it will be overridden, or the old values will be put in there. So this we call it as rollbacking of a transaction. So this will also be taken care by SMON itself during the instance recovery. So which means to do roll forward, we require the new value, that is which will be there in the redo entries, and to do a rollback we require the value in the undo table space. So without these two, either in the case of roll forward or in the case of rollback, if we don't have redo entries or undo values, if we lost that information itself, then we will not be able to perform any roll forward or roll back. So these things are mandatory in order to perform these activities. So is that clear, or any questions from anyone?
One question is like the undo table space data is also written to the data file.
Yeah, of course.
Okay.
Okay, so apart from instance recovery, SMON is having two more responsibilities. One is it is going to coalesce the table spaces, which are defined as automatic segment space management. So what is the meaning of this? It is just adjusting the space. So more clear to say, suppose I have 3 blocks like this before coalescing. So let's say this is before coalescing, and after coalescing it will be like this. So which means when we have data in two different blocks and both of these blocks are half full, So Oracle is going to just put this data back into single block so that it can generate one free block over here. So this we call it as coalescing. So adjusting the rows between the blocks in order to save some space. And apart from that, it will also manage the temporary table space. So we already understood temporary table space will be used during sorting purpose. So let's say user A uh, has utilized the temporary table space, and now already the data of user A is occupied there, but user A data was already given. Then user B wants to now use temporary table space. So before going to give to user B, S1 is going to clear the data in the temporary table space with respect to user A, and then it will give to user B. So basically cleaning up of the temporary table space will be taken care by SMON itself. So coming to the next background process, that is PMON. PMON is having one primary responsibility, that is releasing the locks and resources held by abruptly terminated sessions. Now what is mean by this abruptly terminated sessions? So let's say we already know this, that for every server process there will be a corresponding user process. So from the user process only the transaction will be initiated. So let's say one user process is there and it has issued some update statement on one particular table called T1. So we know server process will do the work on behalf of user process. So especially when you are performing DML and DDL transactions, Oracle internally will use some mechanism called locks. So especially here, let's say user process want to update a table called T1. So what Oracle will do, it will put a lock on this particular table T1, so that other users will not perform the either DML or DDL transactions at that particular time, because if you allow two DML transaction, that may lead to a deadlock situation. So to avoid the differences, it will put a lock on this table, and once the transaction is completed, then only this lock will be released. So assume a situation, update statement has been issued, server process received it, and server process put a lock on this table T1 and it is doing the update. Meanwhile, due to some reason, this user process has been killed. So by mistakenly, let's say that application was closed or whatever with the reason, that user process is not available. Now server process, after doing all its work, when it tries to send the acknowledgement to the user process, because user process is not there, server process will just wait for the time. So it will just wait for that user process to come up. But we know that that user process will not come in. Even though if that same user connected back, then that will be a new session, and for that again there will be a new server process. But the old server process cannot recognize the new session. So any such situations occurs, then PMON will come into picture and it is going to kill this server process because it is having no value. So the moment you kill this server process, automatically the lock on this table also will be released. So this is one primary responsibility of PMON. Any server process, we call that as orphan server process. So any such orphan sorry, so any such orphan server process are there, PMON is going to clear them. Then we already know this. During authentication, we understood about this point, that it will authenticate the user. And later we will be discussing about something called shared server architecture. So that time this point will be helpful. So if your database is in shared server architecture and some instance recovery happen, so during that time it is going to restart the dead dispatchers. So when we discuss about that architecture, you will get to know that. Then DB debtor is having only one primary responsibility, that is writing the dirty blocks from write list to the data files. But it is going to do this action in various situations. Like after log writer writes, we know that already log writer will write first and then DB writer will write. So we call that as a write ahead protocol. Or whenever write list reaches threshold value. So suppose your write list is becoming full. During that time also DB writer will intimate log writer. So log writer will write first, then followed by DB writer. Or every checkpoint, we know that already. Or whenever you take the table space into offline or read-only mode, or whenever you shut down the database cleanly, in all these situations, DB writer will write. Similarly, log writer is also having only one responsibility, that is writing the redo entries from the log buffer cache to the redo log files. So it will also do in these 5 situations, like before DB data writes or whenever commit occurs, etc. etc. So CKPT process, we already understood that it will update the latest SCN to data file header and control file. And archiver also I told you that it is going to uh, I mean, when you enable archelog mode, it is going to take the backup of the old data in redo log files. So coming to data files, those are the actual files where the user data will be stored, or even the metadata of database will be stored. Then redo log files will store the redo entries, and these will be helpful in database recovery. So coming to control files. So till now we haven't discussed more about control files, but control file will have crucial information of database. Like it will store database name, when the database was created, the date and time. Then of course we understood that it will maintain the latest SCN information. Then checkpoint information can also be recorded in control files, and it will store the location and size of the data files and redo log files, like in which locations, in which mount points my data files are located and what is their size, or in which mount points my redo log files are located, what are their sizes. So that information also will be recorded in the control file. And we have some parameters as well, like max data files, etc. etc. So like max data files in the sense how many maximum data files you can have in your database. So let's say if you say 100, your database has reached that limit of 100. In earlier versions, like when you try to create 101 data file and the limit is 100, then it Oracle will not allow that. Oracle will not allow that 101 data file creation in the past versions like 9i, but from 10G onwards, automatically 101 data file will be created, and even this value max data file value whatever is there, initially it's set to 100, it will be changed to 200. So automatically the value used to change in the latest versions. And archive redo log files, those are copy of or the backup of the redo log file data, the old data whatever we have in the redo log file. So those are the things that we have. So apart from that, we have one more important file called parameter file. So We'll be discussing about this parameter file, what it is having, and what is the action extension to that and all in tomorrow's class. So, answering your question, Satish, control file will not have any header portion separately. So altogether it is control file. That's it. So when comes to data file header, obviously header will reside in the beginning of the data file, just like how in the diagram I am showing. So it is in the same way. So if this is my data file, initial some space will be allocated for this data file header. So anyone having any questions? Yes, Satish, exactly. So if my database is having 20 data file, so the SC number will be updated to all the 20. Even if you have 1000 data files also, in all the 1000 data file headers, the SC number will be updated by CKPT process. No problem. You are welcome, Satish. Okay, so let's meet tomorrow at the same time and we'll continue with the further concepts. Thanks everyone for joining and have a nice day.